In this video, I will go over how to find partial derivatives in multivariable functions. Suppose we have a multivariable function. This function has more than one variable. In this case, we have a function of x and y, which is equal to x cubed times y to the fourth plus x squared times y to the cubed. Now we're trying to find the rate of change of this function with respect to one of the variables while keeping the other variables constant. This is where partial derivatives comes into play. So in this case, we're trying to find the derivative of this function with respect to x. This would equal to derivative of x cubed is going to be 3x squared. Now remember, all the other variables are going to be fixed. So y to the fourth is just a constant, plus derivative of x squared. In this case, it's going to be 2x, and y cubed is going to be constant. The rest is simplification. Another way to write this is f of x. Now let's try to find f of y. This would also equal to derivative of the function with respect to y. In this case, we're going to keep the x values as constant. So we're going to have x cubed to be the constant. And now we're deriving y to the fourth power, which is going to be 4 times y cubed using the chain rule, plus x squared is going to be a constant. And we're going to have the derivative of y cubed to be 3 times y squared. Now we'll talk about higher order partial derivatives. What this means is basically we're deriving the function with respect to one of the variables as many times as we want, so more than one times in this case. So let's say we're going to derive this function with respect to x. So we're going to derive the function with respect to x twice. So in this case, we're deriving the function twice with respect to x twice. This could also be written as f of x and x. This would equal, so in this first example where we found the partial derivative, we found the derivative of this function with respect to x one time. So now we're going to derive this function again, and this way we'll find the derivative of the function twice with respect to x. So we're going to have 3x squared, we're going to find the derivative of that. That's going to be 6x. We're going to have y to the fourth as the constant, plus derivative of 2x is going to be 2 times y cubed as the constant. We could also find derivative of this function with respect to y twice. That's going to be f of y. So here, we derived it one time, now we're going to derive the second time. So we're going to have 4y cubed, which is going to be derivative of that is 12y squared. X cubed is going to be the constant, plus 3y squared, derivative of that is 6y times the constant. Now keep in mind that we can derive this function with respect to x or y as much as we want. So we could derive the function 3 times with respect to x. So we're going to derive it with respect to x 3 times. So in this case we will get, so we're deriving this function one more time with respect to x, we're going to get 6 times y fourth is going to be the constant plus 0. So we're going to get 6y to the fourth power. Same thing we could do with y. So we could derive this as much as we want. We could find the derivative of the function 5 times with respect to y 5 times, and so on. Lastly, we'll talk about mixed partial derivatives. Mixed partial derivatives means that we're deriving the function with respect to more than one variable. So in this case, we'll be deriving this function with respect to x and y. So in this case, we're deriving the function 2 times, and it's going to be with respect to x, with respect to y. Now, this is important to note that this means that we're going to find the derivative of the function first with respect to y value, then we're going to derive it with respect to x. And this is also could be written as f of yx. And notice here, in this case, the order is the way it's supposed to be. So we're going to derive with respect to y, then x. So this would equal to, so we could use the second function. We derived it with respect to y, now we will be doing it with respect to x. So we're going to have 4y cubed. We're going to treat this as a constant. We're going to multiply by the derivative of x cubed, and that's going to be 3x squared. Plus, now 3y squared is our constant, times derivative of x squared is 2x. The rest is simplified. Next, we will be deriving this function twice with respect to y and x, which means that we're deriving this function first with respect to x, then y. So let's use, in this case, the first function that we found here. So we already derived it with respect to x. Now we will be deriving this with respect to y. So we're going to treat the x's as constants. 3x squared is a constant, times derivative of y fourth is going to be 4y cubed, plus 2x is going to be our constant, times 3y squared. The rest will be simplified. Now, as you may have noticed, f of yx is equal to f of xy. This is always going to be true as long as the function is continuous. So we're going to have f of xy be equal to f of yx. Now let's take this a step further. Now we're going to derive this function 3 times, or we're going to derive it with respect to x twice, and 1 time with respect to y. So this would mean that we're going to derive, first we're going to derive the function with respect to y, and then we're going to derive it with respect to x twice. So this can be written as f of y xx. So we already have the derivative with respect to y, then x. So if we derive this one more time with respect to x, we're going to get f of y xx. So let's derive this equation with respect to x again to get f of y xx. So this would equal to 4y cubed is going to be our constant, times derivative of 3x squared is going to be 6x, plus 3y squared is the constant. Derivative of 2x is 2. The rest is simplified. We could also find this derivative as many times as we want. We could find it 4 times, for example. We could find the derivative with respect to x 2 times, also with respect to y 2 times. And this could be written as f of y xx, and so on. In order to better illustrate partial derivatives, let's draw a diagram. So we said we have a multivariable function. We're going to take the partial derivatives with respect to x and with respect to y. Now from here, we could find the high order partial derivatives. So here we're going to derive the function twice with respect to x twice. And in the y case, we're going to derive the function twice as well with respect to y twice. So given that we have the derivative of the function with respect to x, now we're going to derive the function again. So we already derived it with respect to x. So now we're going to derive with respect to y. Here we get the mixed partial derivative. Now, same thing with the y function. So we already derived the function with respect to y. Now we will derive it with respect to x. And from here, we also know that these two would be equal, given that the function itself is continuous. If this was helpful, please subscribe to my channel and see you in my next video.